My name is Ian Thompson. I'm from Livermore in California, and I'm going to talk about how the non-physical influences physics and physiology. I'm going to make a proposal for how to bridge the gap between the non-physical and the physical. So the outline of my talk is to explain how this issue is connected with the mind-body problem and how it's related to possible solutions of the mind-body problem. And then the next element of the talk is to explain what I mean by non-physical. I want to be a bit more precise and define it in a positive rather than a negative way. And then in order to find and bridge the gap between these two things, we want to find a soft spot in quantum physics, something where changes can be made. And then I'm going to say that varying the electric permittivity of the vacuum is one such way, one such soft spot in which quantum physics could be changed. And then I show that the result of this is that energy is not always conserved locally, and therefore we shouldn't try too hard to conserve energy locally in order to have the connection between mind and body. And then in order to organize these changes from the point of view of physiology, I'll show how to formulate the idea of targets as a new level of physics in order to see how that works. And then I give some numerical examples of how to change proteins, how to move them or do other things, and then have a summary. The problem that I'm trying to address is that it can be seen in many talks in this convention because they provide evidence for novel causes and lots of effects related to non-physical minds. And we can see these because they have effects in physical things. And in fact, when we think about it, there are many effects of our mind on our body every second, every time we move our finger, because we decide to do so. So we have the issue here of crossing the mind-body gap. In order to address this problem, we have to ask, is there something incomplete about physics? And if there is, can we make a proposal for how to complete it? And could experiments see any specific new predictions? Some of the traditional ways of crossing the mind-body gap are, first of all, monism, which is to say there isn't really a gap because there is a combined physical and mental world that has a uniform system of causes and effects. And according to this view, what is mental is really physical, and what is physical is really mental. So they're the same. But if you just listen to the talks in this convention, you'll see that the behavior that we want from minds are completely different from the behavior of physical things. So it's very strange to say that they're really the same thing. One remedy is called dualism, famously from Descartes, or two levels. There do exist distinct physical and mental substances which are separate but interconnected in specific ways. There's no causal closure anywhere, but there are interactions which have to be spelled out. And people have had trouble spelling out these interactions, but that's what we're going to look at now. My view will be somewhat nearer to dualism than monism because I base my theory of discrete degrees as on a generalized dualism. These ideas come from Emanuel Swedenborg, who talked about discrete degrees in multiple levels. In order to understand what's going on here, we have to understand what some of these multiple levels are so we can say what's physical and what's not physical. And if I draw here first a very quick summary. Blue things are non-physical, things spiritual, mental, intentions, sensory motor mind, a spiritual body, all of those are non-physical, can be included in a general sense of mental. And then in green here, we have physical things. We have physical changes in material objects. And in the middle, there's something which I'm going to introduce in the future of this talk about final causes and targets. I want to say those are physical. So I'm going to focus on this last step into the physical, how the spiritual body and the sensory motor mind make changes in the physical world. And I want to see how final causes, which come from the mental or the spiritual bodies, can create targets which affects what happens in physics. And whatever I do here can be applied to all kinds of input from spiritual or mental discrete degrees. So what I'm going to do is I'm going to describe something like final causes and targets, and I'm going to make them causally active, and I'm going to show how those causes operate. And in these things, I always take non-physical and physical as different kinds of substances connected in ways which we'll see. And you can think of this as I'm trying to show how dualism can work in a proper and rigorous sense. If I'm going to say that there are non-physical effects on physical things, then something must be different in physics and physiology because of this non-physical input. The input targets must make a difference. There must be effects in the general biochemistry of cells, and we would also expect effects in the brain, in the neurons of the brain. And so therefore that's one way perhaps that mental desires and intentions can lead to bodily movements. But in trying to adjust physics, I'm trying to keep the existing structure of physical theory as much as possible constant. I'm trying to make sure that computers and microscopes and suns still work, or at least most of the time. So what I'm going to do is I'm trying to find a soft spot in physical theory so laws of operation of physical things are not always fixed, but can vary as part of a bigger picture, where the bigger picture includes non-physical things, mental, spiritual, whatever. The effects that I want to see happening in bodies are in physical systems. Our bodies are physical systems. They're made of atoms and molecules, and the atoms and molecules are made out of protons, neutrons, and electrons. In particular, they're very large protein molecules in cells. And these molecules have to fold into very specific shapes in order to have the right shape to catalyze a reaction. That makes them into an enzyme, for example. But there's a puzzle about this folding of large protein molecules. The speed and directionality of folding has been a puzzle for the last 50 years, ever since Leventhal posed his paradox in 1969. But I want to work out a way to predict that non-physical influences in living cells could provide targets for protein folding and thus speed up the folding, and to make one way of resolving Leventhal's paradox. I should mention that every year in the science literature, there's a paper or two claiming to solve Leventhal's paradox, but I don't think they've been satisfactory so far. If we go into details in physics, we can see actually discrete degrees even in physics. So if we go from effects to causes, in other words, up the causal chain, we see that all of these things are connected. The outermost physical discrete degree is classical Newtonian physics, made of mostly large objects like atoms and rocks, planets. And all of these can be described by forces acting on masses, giving acceleration. But we know that the behavior of objects is not really exactly Newtonian physics. That actually quantum mechanics is more accurate for small items. So particles that are in atoms and even molecules can be described in some ways more accurately by quantum mechanics. Because instead of particles moving with a fixed location, we have wave packets governed by the Schrödinger equation, and their path is described by interaction potentials. But then we might ask where interaction potentials and forces come from in quantum mechanics. These are, in fact, the masses and forces in quantum mechanics are determined by quantum field theory, which is a discrete degree inside ordinary quantum physics, where we have a field Lagrangian with massive and massless fields. And the variational principle shows how to work out from the Lagrangian how these fields evolve in time. Suppose we want to go even further inside this Lagrangian quantum field theory. What determines these masses and charges inside the Lagrangian? This is a puzzle. To give you a preview of what I want to do, I want to put a new connection between the outermost non-physical, the sensory motor mind, and the Lagrangian masses and charges. So between the blue and the green, we want to have some new kind of connection. And I'll explain later what this connection is. So I'm putting in a new discrete degree, which I think should have been there all along, but people haven't thought about it. This is where some connection should be expected. So the result of this is that the non-physical influences in the minds and so on will influence the values of the Lagrangian masses and charges. But you might have thought that in normal physics, these Lagrangian coefficients, masses and charges, have to be fixed. Many people think so. If you look in Wikipedia for the parameters of the standard model, for example, you can see a long list of 120 or so parameters that have definite values. But the point is, which is not really mentioned very often, is that these are observed values, not the starting parameters which go in to the Lagrangian. And in fact, the initial numbers by a process called renormalization have to be adjusted or tuned to give the observed numbers as output. And the trouble is that the renormalization method is not fixed in the theory. There are many different ways of doing renormalization methods. And in fact, the method you choose could be different at each place and each time. So that means that the starting numbers, even if they're fixed, could give different masses and charges at different places in space and time. So this is a preview of what I see is happening. This middle degree is going to make these things change. You might ask whether physicists have already seen these charge variations. Perhaps if we compare local stars with distant stars, we might see a difference. Perhaps the charges vary between local stars and distant stars. John Webb and his group in Sydney have claimed that they have measured differences in the ratios of spectral lines which depend on electric charges. And they show evidence, depending on the angle, as you can see in the picture here, that the charges are very slightly different, very slightly smaller in distant stars, about 1 part in 100,000. It's not a very big effect, but it does show that charge variations are conceivable in physics. So we've broken the shell in some way. We've shown that something like this is possible. But we want to have not just distant stars being changed, we want to have non-physical effects on the physical, as I said before. And our idea is that the fine-tuned parameters, namely masses and charges, can be varied locally in order to achieve ends in nature. We're going to focus on electric forces. And as I said, physicists have proposed varying charges over the age of the universe, over very long distances. But now we propose to vary the charges in microseconds, very completely different scale, and vary them within living organisms. So this is a new idea which will have to be tested. By varying the electric charge as a non-physical effect, as I said before, we're going to establish a new discrete degree inside quantum field theory, between quantum field theory and the outermost level of mind. So I'm going to call these targets, this new discrete degree. The final causes set the targets or ends, and the ends determine the means, and we reach the targets by adjusting the electrical parameters of physical fields. This is really fine-tuning, because this is not gradual changes over the whole universe or fixing it at the beginning of the universe in the Big Bang, but we're getting changes different at each time and each place in an organism. So from the physics point of view, it's a local, not a global physics variation. And physicists like to do things locally and not just globally. So we're going to suggest that these changes are specific to living organisms and that they occur at all scales in psychology and biology every day and every second of our lives. So let's see how electric forces could be changed. So here I give the standard formula, Coulomb's formula for the inverse square law. The force between charge Q1 at position 1 and Q2 at position 2 is proportional to their product, Q1 and Q2, divided by the square of the distance between them. And there's an overall scale factor of 1 over 4 pi epsilon, where epsilon is called the electric permittivity. It's a scale factor. And you can see that if Q1 and Q2 are the same sign, both positive or both negative, then the product, the force has a positive sign. And if Q1 and Q2 have opposite signs, then when you multiply them together, you get a negative number. And so you get a negative force on this measure. So this is Coulomb's well-known inverse square law. But now I'm going to go on and suggest that we're going to, this new targets, these new influx from the non-physical can vary charges. If it varies Q1, this will vary the force F. Forces will be different because of the different charges. So we're not introducing a new force, but we're just adjusting an existing one. We're not creating a special mental force, for example, but we're allowing mental or non-physical influences to scale up or down in the standard electric forces. And if mental input could vary any of these charges Q, then they could vary the forces on electrons and ions, and they could make things move in interesting ways in cells or wherever there are charged particles. But we're going to actually change things very slightly. Jacob Bekenstein, you might have heard of him from black hole theory, showed that very similar effects could be obtained while keeping the charges Q constant, and as to vary the permittivities, epsilon1 and epsilon2. Instead of having variable Q charges and constant permittivities, we can have constant charges and variable permittivities. The product, the forces now depend on permittivities for both the charges, but the Qs can be constant. And we'll see in a minute why this makes physics a lot easier. And I'm going to now, from now on, to describe the influence of targets and non-physical things on physics is to vary the electrical permittivity, even in the vacuum when there's no dielectrics or capacitors. And the reason that it's better to vary the permittivity and not the charges is that now we can keep constant Maxwell's equations. Here are 4 Maxwell's equations. They govern the behavior of electric fields E and magnetic fields H in terms of rho, which is the charge density, and J, which is the current density. So these 4 equations are responsible for the way currents produce magnetic fields, charges produce electric fields, and how you get traveling waves, light radiation from James Clerk Maxwell. And we're going to allow the permittivity epsilon to vary. That's perfectly allowed by Maxwell's equations. There's no constraint on varying the permittivity, but you can prove from this first equation that charge is conserved. So we vary permittivity, and we vary permeability, mu, for magnetic forces, so that if the epsilon goes up, mu goes down. So that means the c, the speed of light, is constant. And that keeps Einstein happy, because his theory of relativity is based on the constancy of the speed of light. And so we can maneuver a little bit with Maxwell's equations by varying the permittivity in one way, the permeability in a corresponding way, but keep the speed of light constant. So we're trying to preserve normal physics equations as much as possible. Now you need magnetic fields, H, if you have things moving fast. But in living cells, things move slowly. And so we only need the first equation, which I've written down here, in which the charge density rho is the source of the electric field, E. So the rho is the charge density, and it produces E, but the E that it's produced depends on what epsilon is. And that gives the formula we had on the previous page. So this is a very simple equation. It's just a slight modification to the normal Coulomb's law, inverse square law. But now we're in a position to calculate how proton molecules can move if the electric permittivity is changed from, say, some non-physical input. But one consequence of this changing of the electric permittivity has to be confirmed, has to be checked. Because according to Ebbinghaus' theorem from 2015, if the physics laws depend on time, the energy and momentum are not necessarily conserved. If epsilon varies with time, that means energy is not conserved. If epsilon varies with position, that means momentum is not conserved. But here, permittivity depends on both position r and time t. So therefore it's varying in time and space. So therefore energy and momentum are both not conserved. And you can see it immediately here. I write a formula for the electrostatic energy between two charged particles, Qi and Qj. And you can see that it depends on these epsilons, which vary with space and time. But you can still calculate, by the formula we had, the forces between objects once you put in the epsilon electric permittivities. So we can still do all of standard electrostatic theory. There's a lot of work on electrostatic theory with variable permittivities. Mostly they're from water or capacitors or dielectrics, but here we can have the permittivity varying in the vacuum. So it's a bit different, but most of the theory has already been worked out. Some people did not realize that energy had to be varied. It couldn't be conserved if you have time-dependent laws from some input. Many people tried to keep energy conservation and causal closure of the physical and tried to make some extension of physics which kept these two things. For example, John Eccles tried to have quantum mechanics have probabilities which are biased because of some input, for some non-physical input. Henry Stapp tried to vary the time of probabilistic events in quantum physics according to some non-physical input. These two principles would allow energy to be conserved, but they're very small effects. Some people have proposed to move energy from one location to another nearby place, so that the total energy is conserved, but energy is not conserved at each location separately, not locally. Other people have proposed non-local entanglement to communicate across distances, but unfortunately any quantum mechanical entanglement cannot be used for signal transmission. A lot of these proposals involve quantum physics, but chances in quantum physics are very small in living organisms. They're there, but so changes in the chances are even smaller. And these are all much smaller than electric changes that we would get by varying the vacuum electric permittivity. So I think the scheme of varying the electric forces is much more promising to make an observable effect for how non-physical influences the physical. The remaining part of my talk is to discuss how an organism gets to vary these electric permittivities. We've talked about final causes and ends and targets, so let's spell out in more detail how they may work. See, I'm proposing a new discrete degree in the gap between sensory motor, the outermost non-physical in blue, and the Lagrangian masses and charges on the right. So I'm proposing that there is a new discrete degree I'm going to call targets, and it receives final causes or the target configurations from the non-physical, and it influences the physical by using those final causes or final states to vary this electric permittivity. So in the list on the right here, it's number 2, which has been inserted between the other 2 degrees. So if we look at what biologists have already worked out seems to be needed for management of biological organisms, Michael Levin in 2012 looked at cell regeneration from injury and also in growth after transplant. And he deduced that there must be a kind of feedback system within each cell so that it knows the shape that it's supposed to achieve, it has to know its target, and it can tell if its current shape differs from the target. And then if there is a difference, then it, by means of some kind of means ends analysis, it works out how to get from its initial current shape to the target S. And then it has a kind of self-surveillance to know when it's finally got to the desired shape, and it can stop trying to make changes. So this means that our picture from the previous page has to be added by this dashed line. There has to be some feedback from the arrangement of the quantum fields, which tell you where the object is at the moment, to compare it with the target. You have to calculate the difference between the current minus the target and feed that information back to the target. That means targets actually have three functions. They receive the final cause or the target configuration from the non-physical degree above it. They determine the differences between the current state and the target configuration. In other words, see whether they need to make any changes. And then they vary the electric permittivities in order to minimize this difference and so achieve the target arrangement. And I propose to do these three steps. I want to make targets a new kind of physical degree, because I want to avoid using the higher mind itself to micromanage every movement of every molecule in the cell. That's an extreme micromanagement. I want the mind or the non-physical to specify a target and then delegate the process of achieving a target. So that means the physical degree should be able to anticipate futures, work out what's going to happen and then correct it if the wrong thing is going to happen. It has to be able to anticipate the future without using any time travel. And so we have to make some kind of feedback loop in order to keep changing the permittivities until the target is achieved. So you can see here that there are some details which we need to work out. So let's come to this question of anticipating future configurations. Targeting would be much more effective if it could anticipate physical configurations in the near future. For instance, if you have a flying bird trying to intercept an insect, the bird doesn't just try and move to where the insect is now, because the insect will have moved on. So the bird has to anticipate what the insect is going to do or might do, and then try and move to its future position. So the same really applies in cells. Molecules are continually moving because of thermal vibration and movement flow in the cells. So targets would be best specified at some future target time, not just as something that would be good to achieve now. And that would further allow permittivities in the whole time interval between now and the future target time to be adjusted. There's room to maneuver. When we delegate a job to someone, we have to give them some time to achieve it. We don't expect them to make an immediate change and change everything instantaneously. Nothing in physics happens instantaneously. But to anticipate future configurations, we have to separate in physics the idea of metric time from process time. Metric time and process time get to be distinguished, especially because of quantum mechanics, quantum physics. But in fact, Henry Bergson and others, Alfred North Whitehead, also postulated process time, which is the changes of state of an object, the successive internal states, successive actualizations, as in quantum selections. And metric time, or clock time, is measurable like space or space-time. So we all know of space-time is one way of understanding special relativity, Einstein's relativity. But that's spreading all time out like space. It's only dealing with metric time. So we're going to use both kinds of time, but because space-time already exists, you can use it to look ahead and see where deterministic fields get to in the future, because the metric future already exists. Space-time exists at all times already. If we have metric time and we can look ahead, then we can extrapolate the current position to its future time. So we have what we call a current extrapolation. We compare the current extrapolation position to the target arrangement. And this makes much more sense, makes much more effective targeting processes. So we're going to work out a way of adjusting future permittivities, how to adjust the permittivity in the near future between now and the target time. And to do this, we have to send waves backwards and forwards in metric time. We have forward propagating waves, which reveal what the future configuration is going to be. And then we have backward propagating or joint waves to reveal the sensitivity of that difference to changes in the intermediate time. So there's a theory called self-adjoint theory or a joint model theory, which is often used in engineering, which we're using here, is to probe backwards and forwards, just as a human might, and make a plan for the near future to do something. But now it's being done mechanically in a physical system. And we repeat doing this until the physical system reaches the target. So we'll see some examples of this and numerical examples soon. I'm going to show some examples of how targets for proteins might work using molecular dynamical models. So I'm just using classical Newtonian physics to just show how charged particles can move if they're a protein, for example. And the example I'm going to use is a protein with 100 amino acids, each with positive or negative charge. So these negative, red is negative charge and blue is positive charge. And I've put this molecule in a cage modeled on a chaperone cage. A chaperone molecule is a cage in which proteins to be folded are put inside there, and something happens in chaperone molecules which folds proteins up to the required position. Now, the interesting feature is that on the inside of chaperone cages, there are these charges, -3 electron charges. The green ones, they're all negatives, but I've drawn them green at the bottom and orange at the top. There are these charges on the inside of the chaperone cage, and we could imagine varying those in order to repel or attract different parts of the molecule. So this is a very simple model. It's a toy model. And so this is a normal behavior of this system, this molecule, protein molecule inside the cage. But now we want to make a target. And there's a little bit of mathematics of targets, which we don't really need to go into. But basically, G is a measure of how far the target differs from the desired position. So G starts as a positive number, and we want it to go small down to G equals 0. That means we've achieved the target. So I've put this molecule inside a cage, and if we just let it go normally, it doesn't do very much at all. It just sits here, rotating very slowly because it's in the middle of the cage and has much less energy than the previous one. This is a cooler molecule. But now I want this molecule to move left by 1 nanometer, one of these squares, that's 1/1000th of a meter. So I have worked out, I'll show on the next slide, how these permittivities have changed. These permittivities have changed for where the charges are in the molecule and for the electrons in the cage. And so now we see that the molecule moves in a different way because the electric charges have been changed. Sorry, not the electric charges. The permittivities have been changed. So the electric charges have a different effect. The forces from the electric charges are different. It's moved over to position 1. So the target is to move the center of mass of this molecule over by 1 nanometer. And we can see on the left here, this G, the goal function, starts off as 4 and then it drops down to 0. And on the right here, we can see the fractional changes in the permittivity for different units on the molecule and also different charges on the cage. And now we want to show how we can test these predictions. So the general predictions are that physical processes move more quickly to useful result. That's the whole purpose of targets. And furthermore, this happens particularly with charged particles and atoms. It wouldn't happen for neutrons, for example. And the specific predictions are that these electric effects in living organisms fluctuate because of the targeting. The vacuum permittivity changes in atoms and cells in a way which must be distinguished from the permittivity changes from water, say, or other solvents. And furthermore, we note that the model only changes the physics parameters needed to give useful results, probably not all of the region, but just the particular places for the atoms in the causal chain. So these atoms in the causal chain have brief shifts in energies, and their fluorescent light is changed in frequency. So that's one way of observing it. And here we go back to the way John Barrow and John Webb proposed to measure changes for astronomical fluorescent reactions. And so the transitions between levels are different if the permittivity changes. And so therefore, on the vertical scale here, we're varying the strength of the electric field, and we can see transition lines vary in wavelength. And these wavelengths can be measured very accurately with modern telescopes, or all telescopes. So this is one way of measuring that. So to summarize this talk as a whole, we propose two hypotheses to answer these questions. What do mental effects change in the physics? The answer is that they change the relative permittivity of the vacuum. The second question is, how do these changes get to be used in physiology? And the answer to that is that there are target configurations given by input from the non-physical. And so there's a physical feedback mechanism to bring physical objects closer to this target in the near future to achieve these target arrangements. And the overall implications are, now we can see, at least as a proposal, how non-physical things can have effects in nature. And furthermore, these effects on permittivity should be measured because the energy levels in the atoms involved will change. And very interestingly, we have final causes and targets to be active in nature. Final causes have tried to be abolished for the last 400 years in science, but here we have a prospect of bringing them back again. So this widens the field of scientific explanations concerning mental and other non-physical causes. And to summarize, no longer is the physical universe causally closed. So that means that the starting assumptions of so many papers trying to understand the mind-body problem, they all start with causal closure. This is not a good starting point. So there's a few references here for people that I've quoted, and that's the end. Thank you very much.